We're going to begin by modeling what we call bundles or baskets of goods. We're going to use the terms bundles and baskets interchangeably. They mean exactly the same thing. And to understand what a basket of goods is, you can literally think about a basket that contains different quantities of different types of goods. That's what we mean. So how do we model that? Well, let's think about a very simple basket that contains only a single good. Let's say apples. Well, in that case, we'd only need a single number to describe what's in the basket. How many apples are there? So we literally only need a point on what we call the real number line, in particular the portion of the real number line that contains positive numbers. We sometimes denote that as the real number line with positive numbers that's one-dimensional. So if we locate a basket here, that basket would be the basket that contains the number of apples that's indicated on the real number line for that basket. Each point on that real number line is a different basket because it contains a different number of apples. Now suppose that the basket contains both apples and oranges. Now we need two dimensions. We need an oranges dimension, let's call that x2, and an apples dimension, we'll call that x1. So we're now in two-dimensional space. We have two real number lines, both with only positive numbers, but two of them. If we pick a point here, that point represents some basket. Let's call that basket A. It's the basket that contains 5 apples and, let's say, 8 oranges. Every point in that space is a different basket containing different combinations of apples and oranges. And we could represent that basket as just two numbers, 5 for the apples and 8 for the oranges. Just like here, we've represented by a single number because there was only one good, and so we only needed that one number. Now what if we had three goods? We have apples, oranges, and bananas. Well, now we need the oranges dimension, x2, the apples dimension, x1, and the bananas, we'll call it x3. The baskets now lie in three-dimensional space. We denote that as R3. Three real number lines put together to create that three-dimensional space. And if we wanted to see where the basket lies that contains 5 apples and 8 oranges and maybe 4 bananas, we could picture it as hovering in that space. We can picture it by sort of drawing a little box here and seeing where that point lies. It would lie right here. This would be our basket, let's call it A. It would be the basket that's described by the numbers 5, 8, and 4. 5 apples, 8 oranges, and 4 bananas. And you could see that that's what it represents by simply projecting down to the apples dimension to get to the 5, over to the oranges to get the 8, or down to the bananas to get the 4. So when we have three goods, we need three numbers. We're in three-dimensional space. Well, what if we have a large number of goods? Suppose we have n different goods where n is a large number. Well, now we'd need to be in n-dimensional space. That's where that point lies. That's where those baskets lie. But we can't graph that. We can represent it mathematically, so a bundle A might be 5 apples, 8 oranges, 4 bananas, 6 socks, 12 pants, so on and so forth. And that'd be n different numbers to indicate or to fully describe that basket. So you can see that we graph baskets of goods when we have 2 dimensions. We can do it when we have 3 dimensions. When we have lots of different goods, we can't graph it anymore. We can just represent it mathematically as a point in n-dimensional space. But the same concept applies. Now in this course, we're going to do a lot of graphing. So we're going to restrict ourselves to cases where we can graph things. And oftentimes that's going to mean two goods. So you might get discouraged and say, well, all we're going to be able to talk about in this class is a world where there are only two goods. We're going to use a trick to make things more general. So oftentimes there's a particular good we're interested in. Suppose we're interested in housing policy. We might be interested then in modeling the X1 good as something like the square feet of housing that you consume, that you rent. And then we lump everything else together in the second dimension as what we call a composite good. A composite good, and we'll talk a lot more about this, is just the dollars you spend on all other goods. So we represent all the other goods on this dimension with this composite good, where we lump everything together. And that allows us to talk in a much more general way about the good we're interested in, as opposed to all the other goods that you could choose. So we're going to use that trick a lot to make things more interesting and more general. But we're also going to keep in mind that once we get away from graphing and we can use just the pure math, we can just be very general and model any kind of basket of goods with any number of goods in that basket.